Welcome. This is section 13.3, which is integration by parts. So this is the formula you have to remember. And let's go ahead and work this out. It makes much more sense when you work it out. So let's go ahead and look at the first problem here. This is integration by parts. Unlike your differentiation, you don't have a product rule. So I can't find the integral of this, and then, I can't do that like a product rule. So I have to integrate this by parts. So according to the formula, let me go ahead and write down the formula here. The formula says integral u dv is uv minus integral v du. So this is something you have to write on your note card. Now, once I know the formula, what next? What do I do? Your first step is to designate your u. Your second step is to designate your dv. I'm going to take up these numbers here. So first you have to designate what your u is, what your v is. The rule of thumb is when you see ln, by default, your u is going to be ln. Don't think too much. When you see your ln, your u is going to be ln. And your dv is going to be x power 5. Now your second step, or your third step, is you will find the differentiation of u and the integral of dv. Because integral of dv is going to give you v. Now differentiation of du is ln x is 1 over x dx. And differentiation of x power 5, integral of x power 5 is x power 6 over 6. Now, once I have all of these, I will go ahead and plug in the formula. U times v. What is my u? My u is ln x. What is my v? My v is x power 6 over 6. So times x power 6 over 6. Please do me a favor and don't multiply these two x's. They're not the same. Just to avoid the mistakes, just make sure you put all of this in parentheses. Minus, I'm writing down the minus. Integral, I'm writing down this integral here. V, what is my v? My v is x power 6 over 6 times du. What's my du? My du is 1 over x dx. Now, you can simplify. If you can, but there's nothing I can do here. So I'm going to keep that there. And I'm only going to work with this integral. And I'm going to bring this down later. So minus, when I simplify this one, 6, I get x power 5. So this is x power 5. The 6 is constant, so comes outside dx. And that is negative 1 over 6. Integral of x power 5 is x power 6 over 6. And now that is negative 1 over 36 x power 6. Now I can go ahead and bring this down. ln x times x power 6 over 6. I'm supposed to write this down throughout, but I am just being lazy here. So I'm going to go ahead and paste this because it's the same thing. And again, I didn't want to write it down multiple times, but you have to bring all of this down. And that's your final answer. This is not going to change. Once you write this, that is not going to change. You will only work with your integral part and simplify it and find the final integral. And as you can see, I clearly forgot my handy dandy c. And there you have it. Let's take a look at the next one. Integrate. Now they're asking us to integrate. Before you integrate, do not forget your substitution. So you have u is equal to x to the power 10. So your du is 10 x power 9. You see it? You see that? Dx. So what's missing here? I have my x power 10. I have my x power 9, but this 10 is missing. So that's not a problem. What I'm going to do is I'm going to divide by 10 and look what I'm going to do here. I'm going to rearrange my terms. 10 x power 9 dx. So because I multiplied with the 10, I divided with the 10 and I rearranged the terms. And now if you look closely, this is your substitution. This is nothing but e to the power u du, because this whole thing is du. And now this is 1 over 10 e power u plus c, because integral of e power u is e power u. Now go back and bring your u, which is x power 10 plus c. So not all the time you have to use your integration by parts. Depending on the problem, you can go ahead and see, and there you go, the answer matches. Now let's go ahead and take a look at one more. So here I have 4x squared plus 8. So as soon as I see 4x squared, I know that the differentiation is 8x. So I'm going to use u is equal to 4x squared plus 1 du is equal to 8x dx. Now I can see I have my 8x dx and I have my 4x squared plus 1. So I'm going to rewrite this as, I'm going to write this all the way in the bottom here, or here if you can see, I'm going to rewrite this as integral 1 over u du. And you know integral 1 over u du is ln absolute value of u plus c. And now bring back your u. What is your u? 4x squared plus 1 plus c. Your final answer. Now let's go ahead and look at one more problem here. I'm looking at the problem here, 13x, there's no derivative, nothing's gonna work, so I have to do integration by parts. So this is integral, wrong pen, integral u dv is uv minus integral v du. Again, remember, if you have a ln, your u by default is going to be your ln, nothing else. And your dv is going to be radical x, but I like to write that in terms of power, so it's easy for me to integrate. Your next step is to find your du. Integration of differentiation of ln is 1 over x, and the derivative of 13x is times 13. So this one simplifies to 1 over x. Do not forget your derivatives. Now when I integrate dv, I get v, and integration of x power half is x to the power half plus 1 over half plus 1, which gives me x to the power 3 over 2, and divided by 3 over 2, and when I flip it, it becomes 2 over 3, x to the power 3 over 2. Once I have that, I'm going to go back and put it into the formula. The formula calls for u and v, my u and v. So this is my u is ln 13x. I like to put that in parentheses so I don't make a mistake and multiply, times 2 over 3 x to the power 3 over 2. Remember your v, this is your v, minus integral v, which is the same thing again, 2 over 3 x to the power 3 over 2 times du. What is my du? 1 over x. 1 over x. Remember, this part stays the way it is because there is nothing you can do. Maybe you can just bring the terms and rearrange them. That's, in this case, that's the max you can do here. Minus, I'm going to find the integral, but before I find the integral, I want to simplify these terms. So when I divide the bases, I subtract the powers. So this is going to be integral 2 over 3 integral x 3 over 2 divided by x is x to the 3 over 2 minus 1, which is x to the half. So this is integral x to the half. And you know the integral, I'm going to write this down again. 3 over 2. I'm hoping I don't make any mistakes by copying it down. Minus 2 over 3. This is going to be, we already found the integral of x power half, which is 2 over 3 x to the power 3 over 2. When I simplify this further, I get 2 over 3 x to the power 3 over 2 ln 13x minus 2 times 2 is 4, 3 times 3 is 9, x to the power 3 over 2 plus your c. Do not forget your c. All right? Now, let's go ahead and take a look at the next problem. Let's see what this problem says. It says, illustrate the integral graphically and describe what integral represents in terms of area. The best thing I can ask you to do is go ahead, plug this whole thing into your calculator, and you will see that your graph is something like this. Your graph is something like this. Let me expand this. Your graph is something like this. Okay? But you know you are finding the integral. Let's see. Let's go back here really quick. You're finding the integral from 0 to 1. So as you can see, this is 0 to 1, but the graph is not like this. Again, you have to plug this in your calculator. And this is negative 1 to 0. That's wrong. And this is again negative 1 to 0. That's wrong. So the only graph that is from 0 to 1 is this, and this is exactly how your graph is going to look in your calculators. Okay, so you always have to graph it in your calculators to visually see what's going on. And here in your options, it says the integral represents the negative area between the graph from axis 0 to x is equal to 1. They're saying negative because it's below your x-axis. All right, let's go ahead and take a look at this one here. Can I use my substitution here? Let me see. No, I don't think so. So when you cannot use your substitution, your handy dandy tool is going to be integration by parts. And it is integral u dv is uv minus integral v du. I write this again and again so you can see what's going on in the problem. Remember what I told you? If you see your ln, by default, your u is going to be your ln. So your du is 1 over 15x times 15, which is 1 over x. Your dv is going to be x to the, I'm going to bring it to the top, so this becomes negative 2. Now, integral of dv is going to be v. Again, I'm doing the integral. And here, it is x to the negative 2 plus 1 over negative 2 plus 1, which is x to the negative 1 minus 1. And I can rewrite this as negative 1 over x. So now you have your u, you have your v, you have your du, you have your dv. Go ahead, plug it in. uv, which is negative 1 over x times ln 15x. Can you flip these? Of course, these are products, you can. Minus integral v, which is negative 1 over x times du is, I forgot the dx here, 1 over x dx. As you know, that's all you can do here. This is simplified. I'm going to work on this one. This is integral negative of negative becomes a positive. This becomes a positive 1 over x squared dx. And when I find the integral, this is going to be integral of x to the power negative 2, which is x to the negative 2 plus 1 over negative 2 plus 1. And that is, I'm bringing this down. I'm bringing this all the way down. Negative 1 over x ln 15x. This is negative. This is let me simplify this one. This is x to the negative 1 over negative 1. This is negative 1 over x. That's your final answer. But remember, they have given me integral 1 to e. That means I have to plug in the values 1 to e. So it is f of b minus f of a. Don't forget that. So I'm going to go ahead and have 2 parentheses so I don't make a mistake. As you can see, I always write them in parentheses. When I plug them into calculator, I know I'm not making a mistake. So this is negative 1 over e times ln 15e minus 1 over e, because I'm replacing my x's with e's. Now the next is I'm going to replace my x's with 1. So this is negative 1 over 1 times ln 15 times 1 minus 1 over 1. Plug this into the calculator and this will give you, did I get a negative? Yes. This will give you approximately, let me plug, 1.97621. And there you have it. So step by step, again, if you see a ln, that is going to be your u. Now let's go ahead and take a look at the next problem. Here it says integrate. Again, I have to use integration by parts. Actually, no, I don't have to use integration by parts. Look what I'm going to do. U is equal to 4 plus e to the power 5x. My du is 5 e to the power 5x dx. As you can see, the 5 is missing. So what I'm going to do is 1 over 5 integral ln 4 plus 9 5x. I'm going to bring this to this side. E to the power, oops, I forgot the 5. 5 e to the power 5x dx. And again, what is this going to be? I'm going to bring back my u. So this is ln u du, because this whole thing, my friends, is du. And this is u. And now is where you have to write down this formula, because it's easy to remember on your note card. Integral ln u, write this formula down because I don't know if you might find this somewhere, is u ln u minus u plus c. So here my integral, I don't have to do integration by parts because I have the formula. So I'm simply going to write this down. This is 1 over 5 u ln u minus u plus c. And now this is 1 over 5. My u is 4 plus 9 to the power 5x ln my u is 4 plus 9 to the power 5x minus my u is 4 plus 9 to the power 5x plus c. If you want, you can separate this whole thing and rewrite everything as 4 plus 9 to the power 5x ln 4 plus 9 to the power 5x over 5 minus 4 plus 9 to the 5x over 5 plus c over 5. But even this is fine, and that's your final answer. But please, please, please make sure you write this formula down so you don't have to find the derivative of ln by integration by parts. I hope this helps.